Welcome back, everyone. For the final session of speaker at OSDHack'25, we have Ankesh Bharti, sir. He's a co-founder and community steward at Users and Agents. And today he'll be making a compelling case for client-side machine learning. We are very grateful to have you with us, sir, today. And the screen is all yours now.
Yeah, thank you for the kind words. I cannot say how proud I am to see where like the bar that you guys have like made OSTC too. So like I remember in like 2 years, like I graduated in 2022. I recall. Back then, like we had OG seniors like who motivated us and like influenced me, my work. And without them, like it wouldn't have been possible to like dream these things. So I'm really happy that you guys are like the core team. The like you have like really raised the bar for the kind of work we are doing at OSTC. Okay, anyway, going for the talk. Fair warning, I'm kind of sick right now and have ADHD as well. So you can see I have not made the slides, but we will go through this briefly. I will try to not overwhelm you. Uh, So the talk is a case for client-side machine learning. Um, but like brief introduction first. So like I'm Ankesh Bharti. You can find me as Phenon on internet, and as she said I'm a steward at this user agents community. We have similar goals to SDC, but like we're particularly focused on like browsers and local first AI. So case for clients and machine learning. It's about all of us use Chat GPT and all that stuff. It's machine learning, and it's all uh, happens on server side. So this is the slide where I put a case where we can do the inference and the training, and why should we do it offline on our machines locally. And it also aligns with like OSDC values. Like these things are open source, and like it resembles the OS in certain way. Um, and the way we are doing software has changed now. It's fairly obvious. So like previously, we in previous era we used to take inputs and humans used to code functions, and then we like the CPU used to process it and like give us output. Now, now the models are trained on the programs and the inputs, and like, they are functions themselves, and we use that. So LLMs are basically programmable neural net. Yes, this is basically like Chat GPT on your machines. Like it's not your machine as per. It's like a server side thing. You do not have control over it. But like I'll get to the benefits. Like it's not just about control. This pattern was uh, like we saw something similar when like computers started. So like this is Bill Gates and Paul Allen using their terminals, they call it back then. So these terminals, you see these things like these were connected to a central mainframes. So these terminals actually used to share like compute from these mainframes. Similar to use ChatGPT right now. We are sharing these servers, like share of compute from the servers on our machine. So it's like ChatGPT the terminal in this sense. So like so that was the past. So how does present look like? And this past is also in like closed source models. We have open source models now. So like it all happened, like it all took off with Llama, like it's Meta's projects, like all open source. So this is basically the family tree how Llama came to be. Not going in details, but like it was a accumulation of efforts from different kind of open source work in the ecosystem and different kind of academic institutes and stuff. Alpaca was a Stanford thing, I suppose. So anyway, um, so like these models and all these open source models, this kind of resemble like they're like all wrappers on top of each other in some sense. They kind of resemble this like a Linux or like a desktop environments. They are all based on Linux kernel. Uh, yeah. So what are some local like client side running like frameworks, or how would you use them? So we have something called Olama. It's like made from like like these people also made a Docker before. So Olama is you can just download Olama, and I can like show you how that works. So if I go to my terminal, you can see my terminal, right? I think so.
Yes, sir, we can.
Yeah, cool. So this is Olama running on my system. Let me just start it again. I think like I have to say it by. Yeah, okay. So I just need to like Olama run and this like the model's name, and oh shit, and it will load this model. So like a 4 billion parameter model. Billion of parameters is the the size of the model. So this is a small model. It's like 4 billion parameters, which is around like it stores around like four. It takes 4 GB of memory on in your RAM. Of compared to like ChatGPT. ChatGPT is like trillions of parameters there, and it's like 800 gigabytes, 900 gigabytes on their servers. So like it's just like I can chat with this now. It's like running uh, completely locally. It's not a server side thing. It's like not as fast, but does the job. I can show you a few more clients which I use for my personal use cases locally, which makes sense. So there is something called MCP, which is like API for AIs. So my personal banking app has a MCP API now. So what I did was I plugged in my my bank's MCP server, which is like it's called FI, it's a federal bank, and this interface like looks like ChatGPT, but it's not. It's a client called Jan. It has like local models. It's running a model called Gen Nano. It's a small parameter model as well, and I can just ask these kind of things. How was my net worth changed over the last 3 months? And it will call the my banking app, and it will like show me a balance and all this stuff. And like it's quite important that I run this locally, right? I cannot do these things on ChatGPT. I cannot trust that uh, because it's like cloud side. Like, I'm not sure how they would use my data and all that. So it makes sense for this kind of use cases. There are more use cases, advanced use cases. So um, right now on Apple devices and Google devices, you have this kind of stack. They both similar. So I will go through that. Um, so before going through this stack, I will show you some again a demo how that works. So in my Mac, there is this Apple Mail app. So like I can do like typical things, right? Like so this is a fairly long email. I want to summarize. So like if I click this summarize button, it's running it's running locally. Okay, so it will come up with a small summary for this thing. Uh, but it's like it's not like just a typical small model. It's like doesn't work good, but like I will just because like Apple fumbled, but like the architecture is fairly nice. So it's not just like a model just like taking this whole thing and generating a response. They have something called LoRa adapters. Okay, so uh, these are LoRa adapters. Like they did not have mentioned that here, but these things are LoRa adapters. So there is this on-device model stack. So like you have the model here, like single model here, which is like could be like 2 or 3 GB on-device model, and you stick these adapters on top of that. And adapters are basically task specific things. So there is an adapter for just summarizing emails. Like it's like specially fine tuned for summarizing emails. And like all these adapters are like around 50 or 60 megabytes here MB. So you can like this small model in itself is not as capable. If you ask it uh, factual questions, it won't know that. Uh, and like it underperforms in many tasks. But if you like combine these adapters, like you like stick these adapters on top of these models, like it becomes very capable. So like that's a design what Apple went with, and it's the same on like the Google and Android devices as well. So like they have Gemini Nano as their like on-device model, and they have LoRa as well. So as developers, you can train your own specific models. Sorry, like on like based on your own specific tasks. So like you can have like a data set of 300 or 400 samples of some task in your app, and you can train a good adapter for that, which is around, which will be like 100 MB or something, and then you can just uh, embed that inside your mobile app or web app, anything, and can run it locally and at a very good accuracy and performance as compared to ChatGPT. So like it's like it's comparable in that sense. So how would you do that? Um, so there is like I showed you Olama, right? Like I was running Olama here in terminal. I will like close that because taking me I yeah. So there's a library called Olama JS. Like if you want to embed Olama inside your own apps, you can use this thing. Wait, I need to refresh this thing. So you can use this thing named Olama JS. It's a library. So like it's like if you guys are made like on top of OpenAI APIs, it's similar. Like the API endpoint is similar. So you can import this library in your own web apps and like, just use that. There are different kind of API endpoints. So like that's one way to do it. And like there's support to like swap adapters as well. But you have to make an adapter first. So how do you do that? So for that tool, like we have a very Oh shit. I think my TL draw is stuck. I may have to kill a few things here. It's not like thing. Please go. Oh shit, I have to like save flash file. Yeah, no, it's fine. Okay. So if you have to like looking at like training this adapter, so like there's like I'll come like these slides are not linear as such. So like I'm like kind of going from one place to another. So like anyway, if you have to like train this adapter, so there's a thing called Onslaught. Onslaught is a framework, and it's meant for beginners. Okay, Olama is meant for beginners as well. So it's like if you like invest in like 2 or 3 hours, like you can get going pretty fast. So this is Onslaught. And they have like they have very nice documentation. Even if you are like do not have any clue about like how to curate data sets or what these things are, like it will guide you through all these steps. So and it can do these things for free. It's not like you need to have some API key or anything. You can just like open a notebook, and it's a Google Colab notebook. So you can train these adapters. Like it will happen server side, obviously. So like you have to like take the data set and like train the load adapter. But once you have that adapter, then you can export it to Olama from this like Jupyter notebook itself and run that locally. So like it's quite accessible to beginners in that sense too. That you do not need to like spend anything. These are the free, like Tesla T4 TPUs on Google Colab. So it doesn't cost a buck. It will take like 4 or 6 hours to like train once you figure these things out, and it's all Python, fairly simple. So yeah, like I will encourage you guys to try that. Like at least use Olama for like hackathon projects in future. Okay, so back to the slides. So like, but the thing is, like right now it's all static machine learning. So like these models do not really know about you, or like not learning about you like in real time, and it's quite scary as well, right? Like to learn about you, like it's all like on the server side, like they have a, like your persona and all that. So what happens right now? Like they're training their models on this, like whole general web, and like and then they deploy that model, and they have this adapters, and then they deploy that, and then we use it, right? But it doesn't learn you real time, so it's static. So what I'm proposing here, like we need to have a dynamic machine learning, which is like that it needs to learn from your habits each day and like improve on that. I will come to how we do it and what I exactly mean by that. So, but it's fairly compute intensive thing to train. Okay, like we in the present we can do inference. Okay, like we can send prompts and receive responses locally, easy. Like the ecosystem is mature now. We have these small models which are compressed well, which is called quantization and all that. But and like we have these LoRa adapters as well. But again, these LoRa adapters are made at build time, not at runtime. So what I'm proposing here is like we want to make these adapters at runtime. So with each task or with each prompt, it should update its adapters. Uh, so this training is takes we need to have a compute and sufficient memory for that, and we can do that now with like just a base MacBook, which is like 16 GB virtual RAM and kind of this kind of teraflops. I will not specify numbers, but it's doable on base Macs now. And these open source models are like quite capable too. So like we have this, we have like JMA 3 in release, which is a 4 billion parameter model. I just showed you running a 4 billion parameter model in Olama. So it's like its benchmark score is comparable to Claude 3.7 Sonnet, which is like a server side model. It's like better than GPT 4.1 Nano. So these are fairly capable models which are running locally. And you see this, like the performance gap has, like closed in last 1 or 2 years, as you see, like open source and closed source models. And I should not say like open source completely. They are open weight. They are not like completely open source, so that they do not expose like what data they are trained on for obvious reasons, right? Because it's not legal to like scrape on legal books and all that. But piracy doesn't matter as long as like this model is trained. These are things like jurisdictions are taking care of. Anyway, so there are a few companies who are trying to train on like consumer devices. So this is one of those companies. Like the name is EXO, So like they released a paper recently, and they are like training whole models. Okay, not just adapters. They are training whole foundational models on cluster of this like Apple Silicon devices. So these are like, what are they called? Like Apple Minis, I guess. So they they're just connected with all the Ethernet cables, and they're just using this as a like cluster of sorts. And they needed to build a different infrastructure for this, because the thing is with consumer devices we are bottlenecked on uh, compute, not memory. So we need to have a different kind of infrastructure for this kind of things. So this is what paper is about. And anyway, so anyway, like those are the hardware things, right? How do we do even more things in real time? So like LoRa was like a build time fine tuning thing. How do we fine tune these models at runtime? So there are a couple of approaches to do this, and like on device. And I'm making a case to do this on device because because of privacy reasons. On the thing that I'm working on is called Tiles. Uh, this is the copy which I would like to quote. So truly personal AI that respects privacy requires on-device learning from your individual experience. So, so like that's the case to do it on device. It's called like continual learning. So like it's like learning constantly. It's a term that these researchers use. Anyway, so there are like kind of three. Like if we have this three kind, we will go through these three things and like connect the dots. How it is done. So like this thing called model chaining. So like you see a big language model, right? But it's not just one language model. It's a combination of different kind of small models inside, small and big. So this is from like Mid Journey, it's an image generator. So like they have like a different kind of small models in a chain, which is like taking an input and producing output. So we can like take a few of those parts on client side locally and just use that there, and like we can like so like it's a complementary approach. I'm not like saying that we do not need to use server side at all. We need to have a hybrid approach where like we use server side models for the things that they are good at, and use the local models for all the privacy respecting stuff that we want to do. Okay, so it's called model chaining, and the second thing is parameter efficient fine tuning methods. So like it's like so like quite a mouthful, but in short, it's just like doing these fine tuning techniques in a resource like in a parameter efficient way, which is to say with less resources. So like lower adapters, like there are like different kind of approaches which are like I will like give a brief high level overview of. So what you can do is like you can also train like through like recurrent learning. Okay, so like you can give them out reward and like train it just according to a specific task. It's like similar to LoRa, but it's like more compute intensive. It's called recurrent learning. So if you train a small model with recurrent learning, you can achieve even more performance, but at the cost of more compute at training time. So for example, like this is a 1.7 billion model. Okay, it's like a quite small. It's like just 2 GB or something. Like, it takes 2 GB in your RAM, and it performs better than these like Claude Sonnet 4 and O3 at one single task, which is code merging. So this is a screenshot from one of the releases. So you can like have like various small models like trained for specific tasks. Okay, and then this with Gemma 3N model, you can also change how much resource your model is taking based on the like prompts and what your requirements are at runtime. So right now, like what I showed was like just a 4 billion model. It cannot, it takes that whole RAM, it's fixed that it will take 4 RAM for all the time it's running. But with Gemma, it can like dynamically allocate its resources, its model weights at runtime. So this is what like this graph is showing, that you can just take a 4 billion model, 4 billion parameter model, but like you can just make it run with 1 billion parameter. So it's like architecture is made that way. Okay, and there's this thing like last a bit of magic, which like it's like fairly magical. It's like a very recent thing. It's like in research, nobody has made this in production. So this is what I was telling you about. This is from a Japanese research lab. So they use 2 different models. Okay, this is the central large language model and this is a hypernetwork, which is a fairly small model. It's like a 200 megabits model. But this hypernetwork is trained on many load adapters. So what you can do is you can ask some question, and this like secondary hypernetwork will make a load adapter at runtime, and it's doing like 1 MB or 2 MB. It does that in 100 milliseconds. So it will train a custom task specific adapter for you on at the runtime. So like it's like learning from your intent at runtime. And this whole setup can run like it takes 16 GB of memory. So we are not quite there. We need to have like 32 GB of a system or something to like allocate 16 GB to just this setup. But we are getting there, right? Like there are many different compression techniques and all that. So yeah, like that's my talk. Like, there are a few other things I've skipped. But it's fine, I guess. I'm just afraid that this things will overwhelm you more, so I will just stop at this. And if you need to check these links or references for whatever I've showed here, you can go to tiles.run/resources. Like you will find the resources link in the footer here, and I've listed all these links. So yeah, now I would like to audience to ask some questions if they have. Um, and I'm sorry, like if these things like overwhelmed you much, but I tried to make it as accessible as I could. Yeah.
I think we have some questions in the chat. Can you open the chat, Sri?
Yeah, sure. Yeah, sure. Okay, let me see. Uh, okay, I will share my screen again and go through these questions. Share entire screen and let me see these chats. Okay, where do I start? I will start from now. Okay, so imagine we live in a full model, small model, plan thing. Uh, 4 billion parameter model is like actually a small model, to be honest. With quantization, you can even have these things for like 2 GB RAM. So it's quite small, to be honest. Like 8 billion parameter models are kind of big. Okay. I know, like when you compress these models, like in 4 billion parameter model, like if you like normally at the server side they are running in 16 bits, okay, 16 bits. But when you are running it client side, you quantize that, you compress that, and it runs on 4 bit or 8 bit, 8 bit. Okay, so there is no loss of accuracy as such. So it's quite like good that way. Okay, are there SDKs for any other language tool for Olama? I think there is a TypeScript one. I'm not sure if it's in all the languages because they have a very good ecosystem. Okay. Oh, why does you? Yeah. So like this is the thing, right? That's why I'm making a case for like on-device learning. Uh, like right now, Perplexity. Like I showed that like that MCP thing, like which is using like like fetching my bank data, but like the API is itself from the bank itself. So the bank released that MCP server, and I'm just directly interacting with that MCP server through a local tool. So this Jan thing that I was showing you before, it was a local model. It was inside a local client. So like nobody is seeing what I'm doing here. So it's like it's quite privacy friendly in that way. It's Tori based, by the way. So like, this app is Tori, like Rust based, still slow. Okay, back to questions. I think it's just my system. Like many electron apps are running right now. Okay, back to the questions. Um, we have already, so like it just like takes more memory right now. Compute is kind of solved. We just have max. Mac has unified memory, so like, the models that are running, they share the same memory with CPUs. Okay, the GPU shares the same memory with the CPU. It's not the case with Windows devices because you have separate dedicated GPUs there. But like you are seeing ARM devices now on Windows, so that's unified memory, which which should benefit this kind of on-device use cases. And that's the whole Copilot PC thing is about from Windows. Okay, and NPUs, yeah, NPUs are like. They're good for many things, but they're not as programmable. So like all the ecosystem is around GPUs right now. So like it's possible to make an ecosystem around NPUs, and they're trying that, but it's not like as programmable as GPUs. So like the use cases are fairly limited by that. Mm, okay, I think LoRa actors, like they stand for low rank adaptation. So like if you guys remember from the JE days, you remember like studying matrices, right? The like matrices concept. So you have like high rank matrices, low rank matrices. So it's the same thing. So these adapters are basically small matrices that get attached to the like the base model matrices. So it's called low rank adapters. It's a matrix thing. What kind of parameters of you does the AI model monitor to learn? Okay, so so like like learning from your habits is like you can learn in two ways. Okay, so you can just store like plain text files, like and like have it just retrieve it as like a rag thing from your memory. So like that's what ChatGPT does right now. Whatever you chat, and it saves information on you, right? Like based on the prompt that you are sending it, sending the ChatGPT. So like it remembers the facts about you, so it's learning in that way, but it doesn't really know how you use ChatGPT. Okay, so like for example, I like to use ChatGPT. I do not like to write long prompts. I'm a guy which like really like to like write short prompt and throw so much stuff at it. So like if that's one way to do it, right? Some people like are very concise with their prompt, like they write very long prompts and attach less context. So like their workflow is different than me. But ChatGPT does not know that. Doesn't like captures those signals. So if we can capture these signals, and like it's like quite sensitive thing, right? If a tool is capturing your signals, right, like how you are exactly using a thing, then it's quite sensitive. Like they can manipulate that. So then that's the case of doing it on like on device. For example, like on if I give an example for like how they capture signals, so like this is a example of TikTok and Instagram. So um, this is an animated GIF. So like on Instagram, the algorithm, okay, the model doesn't really know how much time you're spending on one single post because it's a feed, it's not a full screen thing. So the signals that it can capture is limited. Okay, so like you can just like scroll away, and like, it doesn't know how much time you're spending on one. Like, are you seeing that top post or the like the post below? So it like doesn't have like full intuition of how you are using the like or consuming inside Instagram. But with TikTok or like like now Instagram Reels, you do not even need to like that stuff. Like you just swipe it, right, and how long you are spending there, it trains the model on that real time. It's happening real time. Like it's a paper that they have also kind of released like 2 years before, like how they train their models real time based on like scrolling. So it's a similar kind of thing that I'm proposing to do it on client side, and it's possible now with all this like advancement that we had in last 1 years. It's all happening last 1.5 years. Okay. Is there anything else there in terms of questions? How NPU differs from a CPU, GPU are a bit different from defined. Okay, so CPU is like a very general thing. Okay, so like CPU is like has very big cores, and it yeah, and like it has like like you see these things like 8 core CPUs, 10 core CPUs. So like they have fairly big cores, so they cannot parallelize as much. While GPUs have many cores, it can even have like I'm not sure like how many they have, but it can have like 100, 200, 300 cores. But those individual cores are quite small. So like individually those cores in GPU cannot do as much. But like it's all based around uh, basically programming, parallel programming. So like it can take like a certain task and like do it, like distribute across these different kind of small cores. Meanwhile, NPU is a very it's just like it's a specific implementation of a particular algorithm to say. So it's like just made for matrix multiplications. So it's even efficient than GPUs at those things, but it cannot do general things, right? So it's like a spectrum in a way. Okay. I did not do a good job of explaining NPUs because I'm not like looked at NPUs as much because I'm still like doing things with GPUs because like, we do not get NPU APIs exposed as much. Apple has fairly big NPUs, but they reserve the NPU access for their own use cases, and they expose it as an API as well. I guess yeah they do, but like it's not as popular in their SDKs. It's a similar story with like other devices as well. But Microsoft is the only company who are like quite focused on NPU development because uh, of their efforts with Copilot PCs. So like they have made it compulsory for new Windows Copilot certified devices to have at least 45 teraflops of NPU compute. So, Yeah, and NPUs are like quite efficient as well. They do not take as much uh, power to say, because they just do one thing well. They just do matrix multiplication. Okay, I think I've covered the questions. Yeah, like Pantheon is really a good show, by the way. Like you guys should watch that. It's like like it really extrapolates where we are today in the present moment to how it will look like in the future. It's like a fairly accurate description, like a portrayal of like the future. And it's quite entertaining as well. Thanks for uh, Timmy here to suggest me that show last year. I actually have a yeah. Anyway, yeah, I can show one more thing by the way, like what tiles was before. Like I pivoted this thing tiles this last month, so maybe I can share that too. So I was working on it was called Tiles as well, and it was a app Tiles, like a notebook app. The work has been paused since, so like it's a Notion like thing. Like it's oh shit, it's on notebook.tiles.run if you want to like check it out. And the source is open as well. You can just check the GitHub. So this was a Notion like thing where you had these agents. You can like just add the it and call these agents. These were like MCP agents. So here, for this example, I'm calling a, a Python execution environment, which is like running locally with it's called pyodide through WebAssembly. So like I give it some prompt and I will run this thing, and it will like give me a financial analysis of my the thing that I call it for. Okay, this the prompt is not working, but I can see here that it came up with a like a graphic description. It's not like as good because I've not done as much prompt engineering here, but like you got this in like an interactive thing, and you can like just take any output and like call other agents here. So there is a demo on the demo video as well, where I'm using Zerodha's MCP server to list my stocks. So if you go to my website and I moved this thing on my website now. So there's a video where like my co-founder was showcasing this Zerodha's MCP server. Uh, let it stream a bit. Yeah, so I think it came up with the results. So like Kite, Zerodha Kite app, and get me a summary of my portfolio, and I can came up with that. You can visualize this interface. So like it did a very nice, not nice as much, but like there's a good deception of what my stocks and targets were in that way. And you can do like you can have all the servers here on the sidebar. You can like call out and you can just like plug in different kind of API keys, and like there are like different kind of local servers as well here, which is running just locally inside browser. But there are also remote servers like like Zerodha and stuff, which are like running server side. So this was what I was working on, but like since then I pivoted a bit, and I'm like working on the dev tool side, which is the theme of this hackathon as well. Yeah. So yeah. Okay. Any more questions? Um, yeah, I think we are done. My screen is sharing quite late. I'm not sure if it's lagging behind. Okay.
Yeah, yeah. I think we can conclude. Thank
Yeah.
you, sir, for yeah, Risha,
And
please.
with that, And with that, we officially wrap up with the speaker session for OSD Hack 2025. A big thank you to Ankesh sir for that truly enlightening talk on a case for client-side machine learning. Sir, we are incredibly grateful that you took the time to share your insights with us, and your perspective has honestly added so much depth to our understanding. We are honored to have had you with us today. Thank you.
Yeah, same for me. Okay, see you guys soon.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Chalo, bhai, हो गई talks.
हाँ चलो
The live stream has been cut off, right?
नहीं, I don't think so.
उसमें उसमें है ना स्क्रीन में
उसमें गया है